LeetCode 56, merge intervals. Sounds simple, but it mirrors real systems like calendar sync, log merging, and scheduling. When data comes in ranges, time windows, file chunks, user sessions, you need to merge overlaps fast. Brute force drags, especially at scale. So how do we turn a messy duck pond of overlapping intervals into one smooth stream? Let's wade in, because the real trick might just surprise you. All right, ducklings, time to splash into our brute force strategy. It's clumsy but clear. Check every interval against every other and merge where they overlap. Let's translate that to code. We'll kick things off with a list to collect the merged results and a Boolean array to keep track of which intervals have already been folded in. Next, we walk through each interval. If it's already been absorbed into another, we skip it. Otherwise, it becomes the seed of a new merged group. For any fresh interval, we set its start and end as our initial merge range. We also set a flag to track if we expand that range in the next scan. Now we repeatedly scan the rest. If an unmerged interval overlaps, we stretch our current range to include it and mark it merged. We keep looping until no new merges appear. Once we're done folding everything into this merged group, we save the final interval to our result list. After scanning all intervals, we convert our merged list back into a 2D array and hand it off as the result. This version has a time complexity of big O of n squared, so 10,000 intervals means up to 100 million checks. It also needs big O of n space to track merges. It works, but big inputs can really bog it down. Let's ditch the brute force and clean up that pond. By sorting the intervals first, we can merge in one smooth sweep, no endless checking. We'll begin by copying the input array. That lets us sort without altering the original, good for safety and interview habits. Next, we sort the copy by each interval's start time. This setup step is critical. It ensures overlapping intervals are side by side. We're building our merged output on the fly, so let's drop in a list to collect results as we go. To start the merge, we grab the first interval as our initial candidate. We'll try to stretch it as far as possible with each overlap we find. As we walk through the rest, we check, does this interval overlap with our current one? If yes, we extend the current end. If the next start is less than or equal to our current end, there's overlap. We merge by pushing the end to the farthest point. But if there's no overlap, we lock in the current merged interval, add it to the list, and reset our merge candidate to the new interval. When the loop ends, one last interval may still be waiting to be added, so we toss it into the result to wrap things up. Now we convert our list of intervals back to a 2D array. That matches the required output format, and we're done. Thanks to sorting, our time drops to big O of n log n. For 10,000 intervals, that's just 130,000 operations, not 100 million. Space stays big O of n, which is totally fine. Clean, efficient, and absolutely ready for interviews or production use. We began with brute force, easy to write, but heavy on comparisons. It checks every pair, which crushes performance at scale. Then we leveled up. By sorting first, we made one smart sweep, merging as we go. That dropped us from 100 million operations to just over 100,000. This isn't just a duck trick for LeetCode, it's how real systems merge logs, sync schedules, and handle streaming data. Spotting where a sort enables a single pass? That's the thinking top engineers and FANG interviews reward. So here's your challenge. What other problems open up when you sort first? Keep paddling and always look for that smarter swim lane.